Now let's just talk about a pin planner. So pin planner is used to plan your pins for your declared input and output. So if you're going to use it at the board. So for example, here we have on this neuron model that we have our W and the X and count and majority detector. So this is, for example, the X and W are axon and cinepass, and then we have output at a count and majority detector. So we're gonna plan it. We're gonna assign it inside a pin planner. The way to do it is to, for example, to go to assignment and then go to pin planner. So and then you'll see that. So one thing to notice, this is the board that we are using. So you must make sure at the lab, before you go to the lab, you have assigned your pin planner based on this board, and then you're going to use the manual, so it must be the same. So this is our names. So if for example, if you don't get these names here, you must, for example, analyze and synthesize the file that you have as top level entity. So those names will show up. So now if we want to assign, for example, our axons, for which are X's, to our pin planner location, so we need to look at first at the board. So if we look at the board here, so for example, these switches we're going to use to flip the switches for on and off for the axon and cinepass. Or for example, we can take the X for example, these 3 inputs, and the second 3 input for cinepass for W. So we're going to assign here, those are our input, 6 inputs, and then our 3 outputs, which are counts. We're going to assign these 2 LED lights here, which is because it's 2 bits, and then for example a majority detector at the lights 4, for example. So we need to go on this model and find the name of these locations. For example, we can go to page 23. So if you scroll down to 23, you can see, for example, here are push buttons and switches. Yeah, for example here. So we have our switches. So we're gonna use these 3 for axons, and then the other 3 for cinepass for W. So the first 3 switches, so it's gonna be AB12, so for example, our first switch X0 here, we're gonna write the first name is AB12, and then we're gonna and then our second is gonna be AC12. So you see it understands the names and they just come up automatically because we're on the same board. And then the last X we're gonna use is AF9. Those are axon, and then cinepass we're gonna use the first input W is AD11, and then the second W is AD12, and then the last W is AE11. So those are for the axons and cinepass. So our outputs, it cannot be switched because its outputs need to be displayed, so like a LED light. So you're gonna use LED light. So if you go to our manual here, so we need to find our LEDs. So you see we have a LED light here. So we're gonna use for our count, we're gonna use the first 2 LED light here. So because it's 2 bits, so it's V16 and W16. So the first bit, it is V16. The first pin, V16, and the other is W16. So those 2 lights, LED light will display our count of 2 bits, And then our majority detector, we can put it. This is where we have our majority function. We can put, for example, in we can just choose which LED light you will display. For example, we can choose LED light 4 here, which is W17. And then you can close it. And then we need to go here and then do our full compiling of all the design. And then we're gonna look at the cost of all the pins and the cost of our program file. So this will take a little while, for example, and then we're gonna. So now it's almost complete. So now we can look at the cost of it. So we can see, for example, we are using a total of adaptive logic modules, LMS, 3 of them, and then we are using a total of 9 pins, which is generally correct because we are used 3 input for Axon, 3 input for Cinepass, plus 3 outputs, which are 2 counts and 1 majority detector, a total of 9. So here is show the summary of all the resources that you have used.